So this is objective 9.1b, and we're going to do this over 2 days. So this is part 1 of the lesson. Today's topic is phase shifts, also known as horizontal shifts, and the essential questions. How do I perform a phase shift of a sine or cosine function? And second, how do I adjust the scale on my x-axis so that my graphs are accurate? Phase shifts are the most complex shift of a trig function because you've got to push the graph left or right, maybe pi over 6. Well, what does that look like on the x-axis? Or maybe 3 pi over 4, what does that look like on the x-axis? So it's a little more complex than maybe pushing a parabola left or right, or a line left or right. So it's really important to take the time to learn how to create an accurate scale. And so the word of the day is persevere. You know, when I say that means that you might have to wrestle with the content a little bit, think about it a bit. Okay, so let's talk about what is a phase shift. A phase shift, and I think I will mark these things in purple here. A phase shift is a horizontal shift of a periodic function. I apologize. Either forward or back a part of a revolution. So typically when we're talking about your cosine and your sine functions, we like to start at 0 radians and we'll graph 1 full revolution or 1 full cycle to 2 pi radians so that we can get the behavior of that graph and the wave. And then we can just repeat the cycle or the period. But with a phase shift, what's happening is you're taking that revolution of 0 to 2 pi and you may be backing it up to negative pi over 4 to possibly 7 pi over 4. So you have to be thinking about, okay, where is this starting on the unit circle? Where am I finishing 1 full revolution on the unit circle? So it's a little bit more complex. This is why I think we'll take a couple days to work on it and attack it and think about it. Okay? And you can have some extra space there in case you want to put some other notes. But let's take a look at these two functions. Now with both of these functions, we now have all of the variables listed for your sine and cosine function. And each of those variables performs a different action on your function. We know that the A term affects your amplitude. And again, you'll remember that that's the vertical distance from the midline of the sine or cosine function to the peak of the cosine or sine function. So there's your amplitude, and your period is affected by your B term, okay? So your period of either function, sine or cosine, is typically 2 pi, but we have to divide that by the absolute value of B, regardless if it's positive or negative. It's a horizontal distance of 1 full cycle of your wavelength. And then C and B create your phase shift. How do you push the graph left or right? So your phase shift is the opposite of C over B. Now this is new. Usually when we're graphing a function and we're transforming functions, we'll take the C term and we'll push the graph the opposite whatever it says. If it says right, if it says +2, we go left 2. If it says -5, we go right 5, right? But now we have to take into consideration the period change that could happen. And then our D term, you guys remember what D tells you? It's your vertical shift. It's just push the graph up or down, right? Up D or down D. Whatever it says, it's just a vertical action. So remember what's happening inside the parentheses with your theta. Those are your horizontal actions. And they are more complex on a periodic function. Vertical actions are amplitude and vertical shifts. Those are easy. Like, I wish it was all just that simple, but it's not. Okay? So your vertical actions are your A and your D, and your horizontal actions your B and your C. And they tend to work in conjunction with each other. Here's something that I want to propose to you. It gets really frustrating when you have 4 different actions to perform on a function when you do them one action at a time. Like you start with the parent function, right? And then you stretch it vertically, yeah? And then maybe you reflect it. And then you push it to the right. And then you push it up or down. And drawing 4 or 5 graphs on the same graph before you get to the final graph, and it's been completely transformed. And so at some point you want to get to the place where you can just pretty much perform all of them within 2 steps or so. So here's something that I propose we try, and if it's not working for you, of course, you don't have to do it. But here's a question. Can I perform a period change and phase shift at the same time or simultaneously? So that I can expedite this process, especially because it's the process that's the most complex. Is there a way you could do both things at the same time? And the answer is, yeah, you bet. You just have to think about how you typically graph a sine or cosine function, just the parent function. You guys know that we will usually start at 0 on a rotation of the unit circle, and we'll go all the way out to 2 pi, and we'll do one full cycle through the sine function or through the cosine function, and we'll get one cycle or one period of the cosine wave or the sine wave. Now what you do with those 2 values is we're going to create an inequality where this is our start and this is our stop of one full wave, and we'll set the quantity that's in our horizontal actions, our bx plus c, in between them. And what we'll do is we'll solve for x, and that will adjust our starting point and our stopping point of one full cycle. Do you understand? Yes? So basically, if we were to go through the process with just the alphabet soup we've got going on here, we would subtract c from all 3 sections, and we'd have negative c less than or equal to bx less than or equal to 2 pi minus c. And that's always a little bit of math when we have to do that. And then we would divide everything by b, and we would end up with the phase shift, which is the opposite of c over b, as our starting point, less than or equal to theta, whatever that is, x, less than or equal to the answer to 2 pi minus c divided by b. And this would be our new start of the wave. This would be our new stop of the wave before we do another period of the same set of points. Okay? So that's something we'll talk about we'll see how it feels for you. And again, if you don't want to do it, you don't have to. It's just an option. Okay, so let's take a look at what we have here. Just these two problems that we're going to do right now. Then I'll have you do some practice. Find the amplitude, period, and phase shift, and sketch the graph of the equation. So here we have the sine function. And let's start with, what's our A? 1. So our amplitude is the absolute value of 1. Okay, what's our B term? 1, right? It's right here. And so that takes the period, which is 2 pi over the absolute value of B. How about absolute value of 1, which is 2 pi. So there's no period change, right? It's still going to be, you'll have to do 1 full revolution to get the wave to complete. And then let's find your C term. So your C term is negative pi over 2. And we're going to find our phase shift now. So our phase shift is the opposite of C. So the opposite of negative pi over 2 over B, which is 1. So our phase shift is pi over 2. So you know what that means? That means that we are going to push the graph right, the sine function. All of the points are going to push right pi over 2. And you guys knew that, right? When you look at that, that's a horizontal action. And we always do the opposite of what it says. And since our B is 1, we don't have to stress. We're just going to push the graph pi over 2 to the right. But let's go through that little process that I just talked about. Now, typically when we would graph the sine function, we would start at 0 and we would stop at 2 pi for 1 full wavelength, and then we'd just reproduce that same wave. What we're going to do is we're going to take our horizontal action here, x minus pi over 2, and we're going to perform the phase shift with the 2 pi period all at the same time. So here I would add pi over 2, add pi over 2, and add pi over 2. So here we get, all right, so now instead of starting at 0 on our sine function, we're going to start at pi over 2. And then we're going to finalize, we're going to have to do a little manipulation, 2 pi plus pi over 2. I might have to write 2 pi as 4 pi over 2. Are you guys okay with that? 4 pi over 2 plus pi over 2 is 5 pi over 2. And so that's still a distance of 2 pi between pi over 2 and 5 pi over 2. Half pi and 2.5 pi, right? That's still a distance of 2 pi, but now our sine function, what we're going to do is instead of starting at 0, 0, we're going to start at pi over 2, 0. And instead of stopping at 2 pi 0, we're going to stop at 5 pi over 2, 0. So when we draw the graph, I think I'll go down one more. Be thoughtful about your scale. All right, so since our amplitude is 1, I'll just go ahead and make my amplitude one tick mark up and down. And then let's see. I think I'll make every other tick mark a pi over 2. So there's pi over 2. Here's 2 pi over 2 or pi. Here's 3 pi over 2. Here's 4 pi over 2 or 2 pi. And here's 5 pi over 2. Now, here's the thing. This is my sine function, right? So if I were to start here at 0, where would I be on my y-axis for my sine function? 0, right? So I'm going to start here on my sine wave at pi over 2, and then up 1, down 1, down 1, up 1, and there I have my sine function. I just took all of my regular sine functions and I pushed all of those points right pi over 2. Do you see it? And so, you know how I discussed kind of cutting out some of those intermediate steps where we are graphing the parent function and then doing the shifts. If you can see that this is your sine functions, period, start and stop, and you can just imagine what's happening, you can avoid doing the parent function. However, just to support those of you that would prefer to start with your parent function, sine of x, these are the points that you would typically, or you would graph. And then all you're doing is pushing all of those points right pi over 2. Okay? Up to you how you want to handle that. Do you have any questions? Questions? No? Okay. Then we got one more to do and then we're done for today, and then you can do some practice. So the next one here is a cosine function, which got an amplitude change and it's got a phase shift. So let's identify our amplitude. Our A is 4, so our amplitude is, well, remember it's the absolute value of 4, which is 4. So all I'm going to do, instead of on my y scale, I'm not going to go by 1 and -1. I'm just going to mark 4 and -4, and I'm just going to draw my cosine curve. Okay? So I'm just going to adjust the scale on my y-axis to go up 4 and down -4, and that'll be my max and min. Your b term is 1. So your period is 2 pi divided by the absolute value of 1. I think you guys have got that by now. Okay? And then your c term is pi over 4. So we're going to use b and c to find your phase shift. So your phase shift is the opposite of pi over 4 over 1, or negative pi over 4. So basically that's telling you you're going to push all of your points left pi over 4. You're shifting the graph. Instead of starting at 0 and going to 2 pi, you're going to start at negative pi over 4, and you're going to do one full revolution to 7 pi over 4. Watch, that's how it's going to work. So it's a cosine function. So one full revolution would be 0 to 2 pi. And if we take our horizontal action, x plus pi over 4, and we affect that start and stop by shifting everything pi over 4 to the left, we'll be starting at negative pi over 4. So we'll have to go a little bit left on our x-axis on the negative side. Is less than or equal to x is less than or equal to. So 2 pi, if I write that over 4, would be 8 pi over 4. So 8 pi over 4 minus pi over 4 is 7 pi over 4. That's still a distance of 2 pi. That's still a period of 2 pi. But this is now my new starting point for my cosine cycle and stopping point. So when I graph, as I mentioned, when I go to do my scale on my y-axis, I'm not even going to graph 1. I'm just going to make a mark at 4 and -4 because that's my amplitude. There's no vertical shift, so I don't have to adjust that. And then I'd at least like for all of my graph to be on intersections. So if I make this pi over 2 and pi, and 3 pi over 2 and 2 pi, I can get my pi over 4s in between. That's pi over 4, 3 pi over 4. So now I'm just cutting my unit circle into 45-degree angles. Excuse me. 5 pi over 4, 7 pi over 4. And then over here, negative pi over 4. Okay, so we'll graph the cosine function from negative pi over 4 to 7 pi over 4, which is a period of 2 pi. Now, you might have to imagine what's happening here by maybe just sketching out a couple points of the cosine function without any phase shifts. Like cosine function with an amplitude of 4 would start at 0, 4, right? And then pi over 2, 0. Okay, that's good enough for me to see how far apart my points, my maximums and zeros and minimums are. So from here to this point, I went right 2 and down 2. Okay, so that's how I'm going to space my cosine function. But instead of starting at 0, 4, I'm going to grab my red pen here. I'm going to start at negative pi over 4, and I'm going to stop at 7 pi over 4. Cosine function does that. And then from this point, I'm just going to go right 2 and down 2, and right 2 and down 2, and then go back up, right 2 and up 2, right 2 and up 2. And there you have your cosine function with an amplitude of 4 and a phase shift of negative pi over 4. The tip that I'm going to give you here is this. I am asking you to draw accurate scales on your graph. So if by chance, and it's going to happen, you have a phase shift of, say, pi over 6. Okay? Are you hearing me? Pi over 6. So, for example, let me get some free space here. Don't worry about that. That's tomorrow's notes. But, so say you have a phase shift of pi over 6. So when you go to create your x-axis, what you want to do is make sure that a pi over 6 is actually on a tick mark. So if this is pi over 6, 1 tick mark equals pi over 6, you have to think about, okay, how does the rest of my scale, how do I keep that scale accurate so that I can get my pi over 2 and my pi? So this is pi over 6, right? 2 pi over 6, yes? 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6 is pi. So you just need to be really careful about that so that you can use the graph paper and the little boxes to help you shift do your phase shifts. Okay, so just think about that. So what you could do is think, okay, so 2 pi or pi over 1 and pi over 6, if they have to have common denominators, right, you have to go times 6 times 6, right? Yes. So for 2 pi, you'd have to go out to 12 tick marks, right? Right? Yeah. Yes? So just be really careful and thoughtful about, before you create your graph, be thoughtful about the scale that you're creating and make your scale or reference your phase shift to help you to create your scale. And then I'll help you with that as the period goes on if you need it. Okay, the assignment's on Canvas. It is a 9.1B part 1, problems 1 through 10.